Okay. So if you want, we can start.
Mm-hmm.
And Marco will introduce you with a short introduction.
Perfect.
Good evening. Can you hear me?
Yeah. Hi.
Yeah.
Perfect. So I just want to share for a second my screen. Okay, anyway, doesn't matter. So anyway, hello everyone, and thank you for being here today. We will discuss about the sustainable energy in the global food value chains with Dr. Manias Puri, which I thank again, and I would like to introduce you. Dr. Manias Puri is a sustainable energy expert in the field of agriculture that works for FAO and is experienced sustainable energy professional, which has gathered several years of experience in analyzing and deploying sustainable energy solutions across value chains. Also, he holds a bachelor's in physics and he has a PhD in economics. In particular, Dr. Puri is mainly interested in using clean energy technologies to increase agricultural productivity by modernizing the food value chain to be more efficient and reducing food losses caused by lack of cooling and processing infrastructure. He joined FAO Climate and Environment Division after finishing his PhD, and from that moment he has supported several countries, Africa, Asia, and in the Near East in developing evidence-based energy and agriculture policies that can support the country's transition to a low-carbon, sustainable agriculture sector. That was all. Now I would like to leave the word to you, Dr. Puri, and thank you again.
Thank you. Thank you so much for the introduction. Actually, I must say, I also finished my PhD from Tor Vergata. So I'm an ex-alumni of the university.
Welcome back.
Thank you. So thank you for the presentation. And in the introduction, as you pointed out, I work with FAO, and my main area of interest is actually looking at the agriculture value chains in several countries in trying to understand how to modernize them. In that, how to make them more efficient, at the same time reduce carbon emissions from them. So the whole idea is to look at, the link of agriculture, energy, and climate change and all. So today, what I'll be talking about, I'll be giving you a very brief introduction of the kind of work that we are involved in, and with some examples of how sustainable energy use can be deployed in agriculture value chains. What are the current challenges that many countries are facing in modernizing them, and also some of the opportunities that are coming in. This is broadly the agenda that I will be going through. So very broadly, I will start with what exactly is an agriculture value chain, and then after understanding what is the energy and agriculture link in the agriculture chain. From then we would go to talk about how does access to energy impact the agri-food chain? Why is it important? And if the lack of energy exists in the agri-food chain, what are the negative impacts on, on people, but also climate? Then, because we don't want to be always very negative, we will also talk about some of the opportunities. What are the positives that are coming out from different countries in the world? And some of the more promising technologies that are emerging that brings many of the actors in the agriculture value chain to bring together and to solve a common challenge. Then finally, we would look at what FAO is trying to do, and then we will have time for some question and answers. So what is the agriculture value chain? Well, agriculture value chain is simply a very set interlinked activities that bring the food that is produced on the farm to the plate, as we call farm to fork. Now it involves several steps. The first one is, for example, the production of inputs. So how do we produce seeds, the irrigation pumps? These are the inputs that go in producing food. So we have seeds, we have irrigation, we have livestock feed, everything that goes to the farm before the growth starts. The value chain starts from here. Then at the production stage, we have equipment such as mechanization, we have tractors that go into, that's the second step of the chain. You need tilling, we need water, we need pumping, we need collection and harvesting. Now, once the food is harvested, then it is transported from farms to collection centers. And in collection centers, there can be many things. You need to have proper storages. You need sometimes you need cold storages, sometimes you need warm storages actually. So it depends what kind of storage we are looking at. From there, we go to value addition, as you can see here, which may be depending on what kind of food we have. So if you have something like rice or wheat, the value adding process means that using that wheat grain to produce into flour, that in farina, that we can use to make other things. After that, generally the it goes to the retail and marketing systems. Again, there is a transportation involved before it comes to us, the final user. So as you can see, getting the food from the farm to where we need it is not a very easy process. It is a very intensive process. And globally, what has happened is all of this right now is very, very intensive in terms of energy. At each step of the chain, you can see you need some form of energy. You need petrol for transport. You need cold storages that require electricity. So the food chain as such is very intensive in terms of its energy use. And right now, what's happening is everything is derived from fossil fuels. And we all know that fossil fuel burning causes climate change. So if we look at the current chain right now, at each step of the value chain, there are different kind of energy that is used. So at the input level, we need natural gas and electricity to produce, for example, fertilizers. At the transport and production stage, we need a lot of tractors. Globally in the world right now, there are 25 million tractors, and every year we add 2 million more new tractors. And all of these tractors use petrol or gasoline or diesel to work. And that has an impact on the emissions. And the third and the fourth stage we need for cold storages, because if you have tomatoes and horticulture product that can perish or decay very easily, you need cold storages to reduce food losses. And for cold storages, we always need access to electricity. And then it also depends how that electricity is made. Currently in the world, we have 616 million cubic meters of cold storage. All of this right now is powered by fossil fuels, which again causes greenhouse gas emissions. At the cooking stage as well, we cannot even, we need energy to cook food before we can eat it. So we need access to either in developed countries like in Italy or in Europe, generally we have LPG, which is the liquefied petroleum gas, or butane. This is a fossil fuel. And in developing countries, there's a lot of the times in Africa, you have biomass. Biomass is basically anything that you can burn from the tree. So wood fuel or briquettes and pellets. So as you can see, each step of the value chain needs energy to operate. And when there is no energy, it's very difficult to bring your food from the farm where it is grown to where it is required. Now, if we look at the global scenario globally in all countries, it's incredible that 30% of all the energy that is produced in the world is actually consumed by the agriculture value chain, 30%. And this results in 20% of the total greenhouse gas emissions in the world right now. And if you look at the different kinds of countries, so different countries consume energy in a different way. So this is a graph that tells you in high GDP countries, where most countries in Europe, most countries in North Africa, North America, sorry, they consume more energy at the processing stages, at this stage. This is where we take raw food from the farm and process it into something else. For example, we take wheat from the field and we grind it to make farina, or we take tomatoes. We take the tomatoes and then we make tomato sauce from it. So most of the energy in developed countries is consumed at this stage of the value chain, in the processing and distribution stage. In developing countries where infrastructure is not really available, they don't have a lot of factories, they don't have a lot of entrepreneurship around the agri-food chain, most of the energy is actually consumed at the end stage of the value chain. So in cooking, most of the energy is consumed here. So there are differences in different countries, but why do these differences exist? There are many causes, but to see the trend, you see that Europe and North America, the amount of energy used in the agri-food chain is very high. So in Europe, for example, it is high, but it is going down because efficiency is increasing. In Europe, there are technologies that can produce the same amount of food but use less energy. But if you compare this to Africa, it is very low compared to Europe, but it is also growing very fast. So this presents a big challenge. We do not want, what we want to avoid is to get to a planet where every country is consuming a lot of energy to produce food. For example, if imagine if all of Africa, all of Asia, Oceania, all of us start to consume the same amount of energy that Asia is doing it now, or Europe does, then we don't have energy enough in the world to actually produce or consume that food. So the idea is to, how do we ensure that we produce the same amount of food but we consume less energy? And the amount of energy that we consume comes from renewable energy and not fossil fuels. These are the two objectives that we are working with. Now, then the question is, why are the differences across region? Well, these differences exist because of mainly on income levels. The farmers and the actors involved in the agri-food chain, how prosperous they are, how much income, how much money they make depends or defines what kind of technology will they be using. For example, this is basically some of the actions that we need in the agriculture value chain. So before you start to grow food, you need to till the land. You need tractors that work with the land to remove the soil so that then you can plant the seed. We need irrigation, we need processing. Now, a subsistence level farmer in North Africa or East Africa, let's say in Rwanda, all of these processes are either done by humans or animals, you see. Generally in Rwanda, for example, in small scale farmers, for tilling it's human labor, for irrigation it's manual. Somebody is there to get water and then and spread it in the field. Processing is almost zero. There is no mills, for example, to process food. It's all done by hand in old technologies. Now compare this to a high income farmer somewhere, let's say in Europe or America. For tilling, there is a tractor, there's gasoline, which is powered by gasoline or diesel. So there is emission involved. This increases emission, but also increases the efficiency of the operation. For irrigation, whereas a farmer in East Africa would be using human labor or gravity, which is basically a slope in the ground to move water. Same farmer with high level income in, let's say, developed countries would be using a water pump to move water. So what this does is, at this level, at the subsistence level, it reduces the efficiency of operation. So what a high income farmer can do in 1 hour, a low income farmer would need 14 hours to do. So it reduces the amount of money you can make in the end from your growth. On the other hand, a high income farmer is producing more emissions than this one because there is no use of fuel at subsistence level in poor countries where there's a lot of greenhouse gas emissions because of the fuel used in high income farmers. So there are differences, and these differences are essentially based on your income level. All subsistence farmers in the world want to move to high income farmers and start using gasoline and fuel. Now, if that happens, how do we mitigate the risk of then super high greenhouse gas emissions in the country? An addition important thing that causes this difference is the level of processing technology involved. As I was saying, in most developing countries, processing does not exist. Everything is more or less everything is eaten raw. It's not packaged. You do not have cans with tomato sauce in it. It's all raw. So this stage of value addition is completely non-existent, and this stage is very energy intensive. You need a lot of electricity to produce tomato ketchup from tomatoes. You need a lot of energy to produce pasta that we buy in the supermarket from wheat and farina, from wheat flour. So of course there are differences in income levels, but also there are differences in how countries have the capacity to process food. And in developing countries, generally this is very low. For example, this is the graph that shows how much energy you need to produce, let's say, 1 kilogram of milk and cheese. So to produce 1 kilogram of milk, it needs 5 units of energy. Forget about this. This is a unit of energy, but we don't need to understand that right now. To produce 1 kilogram of milk, you need 5 units of energy, but to produce 1 kilogram of cheese, you need 50. So the amount of energy used to produce 1 kilogram of the same dairy product from milk or cheese, depending on how you do it, you need 10 times more energy. So the more processing you do of milk or any commodity, the more energy you spend. Now, if all this energy is coming from fossil fuels, from petrol or diesel, you also emit 10 times more greenhouse gases, which causes climate change. And there are differences again. In high GDP countries, around 45% of the energy is spent in food processing. That's a lot because there is capacity to process, whereas in Africa, this does not exist. But then the question is, why is low energy use an agricultural problem? We know now that the amount of energy used in the agriculture food chain in Africa is much lower than, let's say, from the USA. But why is the problem? Because in one hand, it should be good because there's low energy use in Africa, which means there's also low greenhouse gas emissions, which is nice. But that's not the entire picture, because low energy use in agriculture also results in a lot of negative things.